We'll be continuing our lesson on data, and as you might have guessed already, we've talked about collecting data, we've talked about organizing the data into a table, and therefore now we'll be looking at how we would be able to analyze the data. There would be proper mathematical calculations that we will be able to use and help us tell something more about the data. 3 M's: M, mean, median, mode. And just like any data, or maybe in any exam that you will be doing in class, you would probably say that, Miss, who got the highest? All right. Sometimes some people would say who got the lowest. All right. But most of the time, what people would actually want to know wouldn't be the highest or the lowest, but it actually would be, what's the middle, Miss? Or most of the time, I hear the word average, right? So when we say average, we want to find out the middle, right? And this measure is what we call the measures of location, right? Let's introduce some new words for you guys today. So we've got measures. Ooh, it's purple. Measures of location, right? Sometimes this is called measures of, it's a little bit long, central tendency, right? Pretty long measures of central tendency, but it's actually what you call your center of the data, right? Or most of the time, people just call it what's the average, okay? What's the center of the data? And most of the time when they ask the average, there's what you call your layman's average, which is what is actually what we call the mean. So this is the layman's average, because most of the time when people are asked what's the average, what they do is they add all the scores and then divided by the number of scores. Looking at that, right, you would probably be able to figure out straight away what would be the lowest score and what would be the highest score. But that wasn't the lowest, was it? Right, so the lowest score would be 63 and then the highest score would be 100. But most of the time, what we want to figure out would be what would be the center of the data, or what would be the middle score, what would be the average of her scores, right? And when we say mean, that is actually what the most popular average is. That's why it's called the layman's average, right? Because everyone else know how to like get the average, right? What they do is they add the scores, they divide by the number of scores that they added. Can anyone get a calculator for me and figure out for us what would be Abby's average or mean? The symbol, the mathematical symbol, we'll be learning a lot of new words and symbols today, right? So the mean, the symbol for that is usually with an X with a bar on top, okay? So what do we need to do? We need to add all of them up. We've got 9 scores to add, right? So we've got 86, 97, 84, 73, 63, 88. And if you've got the answer and you're quite faster than me, then you're welcome to unmute yourself or type on the chat. Yep, 87. Okay, so we added them and then divided by the number of scores. There are 9. Okay, let me just introduce you with more notations. Okay, now this is the sum of the scores. There is a proper notation in maths that they use. We call this, or we read this as the summation, right, of all your x's, right, divided by n. Okay, so x would be all the scores divided by the n, which is your frequency, right? So x scores where X are the scores, and then N would be the frequency. Okay, so what this means is that if we've got the first score, we add that to the next score, we add that to the next until we've exhausted all those scores, right? But divide that by N. Yes? Okay. So that's the summation of X, or sometimes you can just say, to make it simpler, sum of X divided by N. The same thing with this one. So you just add all of them up, right? Then divide by the number of scores. Now, is there any way you'd be able to shorten this when you put them onto the calculator? Does anyone have a strategy for this? Do you want to put 0 plus 0 plus 0 plus 1 plus 1 plus 1 plus 1 plus 4 plus 4? Or would that take too long? Multiplication is just a repeated addition, and therefore you can say that's 0 times 3 plus 1 times, how many ones are there? You've got 1, 2, 3, 4, 5, right? And it saves you a lot of time. Is there 4 fours? In putting that onto your calculator, and also checking if you've actually put in what, 4 fours, 5 ones, right? 3 fives and 2 sevens, right? And then you can just divide that by the number of scores that you added. You've got 3 plus 5, 8 plus 4, 12 plus 3, 15 plus 2, and therefore you've got 17. And you'd be able to figure out as well straight away what would be the N that you'd have to use, okay? Rather than keeping on counting them each time, right? So that could be a good strategy that you can use. Now, sometimes when we have, for example, maybe if we use Abby's scores here, maybe there was a day that, you know, her stomach was upset and she didn't finish that test, and maybe the score of the test that she did, she was only able to finish halfway through, and therefore that science test score would be, let's say, 35, right? So when you have a 35 as against all these other scores here, what can you say about the 35? If I would be calculating now, let me change the color. If I would be calculating the average now of Abby's science score and add that 35, and therefore I would have to, instead of divide it by 9, I would have to divide it by 10. What do you think would happen with Abby's average score or mean score? Her mean is 87, right? If I add her score, which was 35, what does that make? What does that do to her average? Or would her average go bigger, or would her average go smaller? It makes the average smaller, right? Because then it pulls down all, whatever score, the lowest score would pull down, right, the center, right? But you would see that most of the other scores would be clustered, but 35 would be far away from all the other scores, okay? 35 is what we call an outlier, okay? So an outlier would be a very, very small number as compared to the other scores, right? Or it could be a number that's really, really high, right? Which is away from most of the scores. When we have an outlier, what do we usually do? There's actually another measure of center for her to determine, right, the center of the data by ignoring the lowest and ignoring the highest, okay? And it would just be looking at the center, the middle, right, precisely the middle of the scores, okay? And that is what we call the median. Median sounds like middle, right? Okay, let's probably use Abby's scores for the median. Now, when we say median is the middle score.
I couldn't hear what you said.
Someone is eavesdropping. Okay, what was I saying? All right, so we use the Abby scores here, right? When we say middle score, it's the middle score of an ordered set of data. When I say ordered set, then it would have to be from smallest to largest, okay? So we said we'll be adding the 35. So let's write them down. Write down the scores, Abby scores from lowest to largest. We've got 35. And then what next? 63, 73. Let me know if I make a mistake. 84, 86, 88, 95. Did I miss anything? 95, 97, 97, and 100. Okay. Got 2, 4, 6, 8, 10. Perfect. Because originally she had 9 and we added the 35, which is the lowest score, right? And now we've got 10 scores. Okay. Now, when we're looking for the median, we said median is the middle score of an ordered data set. Okay, so when we're looking for the middle score, what we want to do is, well, what would be is to divide the data into two halves, into two equal parts. Okay, so then we've got the same number of scores on the lower half and the same number of scores on the upper half. Okay, because there are 10 data sets there, then you could say that there should be 5 scores on the lower half and 5 scores on the upper half. So you've got 1, 2, 3, 4, 5. You can say 1, 2, 3, 4, 5. You can say that you would be dividing that as your lower half, upper half, yeah. Okay, so your median is the middle between these two scores here, 86 and 88. What's the number between 86 and 88? Anyone? 86 and 88 was the middle, 87. So the middle between the scores 86 and 88 is 87, and therefore this is the median. Okay, right? And you see, even if we've added a really low score, right, of 35, what was the center? We got still an 87, and it did not actually affect, right, our middle, right? It does not distort your middle, right? Because then it ignores those extremes, okay? But if we would be actually calculating the mean, can someone add these for me, please, and then divide by 10? What did we get? If we considered 35 and we used the mean, what would she have gotten as her average? It would have been 81.8, or let's say 82, right? Which it actually, that score pulled her average down, right? But when you have the median, then it ignores those really low scores and really high scores, okay? Because we know that her scores, pretty much it's a bit, consistent here, right? But with that 35 was an unlucky day. She wasn't feeling well, okay? So now, what if it's an odd number? I like that question, Philip. What if it's an odd number? Okay, so for example, let's have a look at if they've given us an odd numbered example here. How many scores do we have? 2, 4, 6, 8, 10, 12, 14, 15. Okay, so that's a really good example there. So we've got 15 scores here. It's an odd numbered data set. we want to firstly arrange them in ascending order. We want the same number of data sets on the lower half and the upper half. If we circle that, right, we've got 1, 2, 3, 4, 5, 6, 7 scores here. Do we have 7 scores here as well? The median would be one of the scores. Okay, if it's an even number data set, then you'll have to get the median from getting the average between the two middles, right? But if it's an odd number data set, your median is actually one of the scores in the data. There's 7 scores here and 7 scores on the other side. Does that make sense? Therefore, this is our median. Let's use your numbers. I like that. 10, 23, 46, 68, 68, 73, and 98. Okay, so we've got an even number data set here. So what we want is to divide this data set into 2 equal parts. We have now 2 middles, 46 and 68. I won't be able to visually figure out what the middle of that. So what you need to do is to get the mean of those 2 data sets, right? So if you add them and then divide by 2, then you will be able to get the middle. Okay, so what's 46 and 68? That's 114. And then divide by 2. Half of 100 is 50, half of 14 is 7. And therefore, that's 57 as your median. Does that make sense? Really, really like the questions that I'm getting today. Okay, now the last M, all right? Now we talked about types of data. We said that the data that we would be able to collect, they can be numerical or that they can also be categorical. Okay, now when they're numerical, then we've got 2 ways to get the center of the data. But what if you're actually looking for what the most popular lunch order and it doesn't have a number? What would you add? You won't be able to add pizza and burger and something else, right? But what you would need to do would be what? You would have to come up, or the mathematicians had to come up with another measure of center, which is what we call the mode, right? And the mode 3, which is mode, M-O-D, M-O is most often. Okay. It's the number or whatever category that is that occurs most often, right? Mode would usually be used for categorical data, but in our examples here, right, the mode would be, the data set would be numerical as well, and you could still use that, okay? So looking at this one here, you've got 2, 3, 4, 5, 5, 6, 6, 7, 8, 8, 8, 9, right? The one that would be most often would be 8, okay? The one with the highest frequency, right, would be 8, right? The most popular maybe shoe size would be size 7, right? And then size 9 or maybe size 5. Would you make more of the size 6s? No, right? You wouldn't be getting the average of them, but you will have to consider both of them, right? Just like when you have a popular lunch order and it's a vote between pizza and burger, they had the same number of votes, you wouldn't be mixing them up, right? Or maybe just ignore one of them. But what you want to actually do, oh my goodness, what you want to actually do is to make more of both, right? And therefore you have got 2 modes, and this can happen, and this is what we call a bimodal data set. Bimodal means you've got 2 modes, right? If, for example, none of them would be repeated, what happens? You can also say that there is no mode. There wasn't any winner, all right, when you had that survey. Okay, so it can be that there's one mode, it can be two modes, or no mode at all. So if all of them occurred 3 times, then there is also no mode. The last one is the measure of spread. How spread is the data set? Measure of spread is also called the measure of variability. And the first measure of spread that we will be discussing, the other measures of spread that you will be figuring out or calculating, you would learn in year 9 and 10, okay? But just so you know, if we have 3 measures of location, there are also other measures of spread, all right? But what we'll just be talking about this year and the next year is what we call the range, right? And when we say the range, usually when you say what are the range of your scores, you'd say from 35 to 100, right? But when you ask what the mathematical range is, we actually minus them too, right? So it's the highest score minus, let me write out minus the lowest score. Okay, so with Abby's range, it would have to be, the original one is 100 minus 63, right? Which is 37, right? So her range would be 37, okay? Now, when we added the 35, let's just compare the range, the first range and the second one, minus 35, then that would be, is that 65? Right. What happens with the range? It becomes bigger, and you are right, Philip. The lower the range, right, the better the scores are, because then we can say that the scores were consistent, right? And the bigger the range, right, would be less consistent. Right? You don't want things to vary. We don't want them to go up and down, just like probably the COVID cases, because then if they go randomly up and down, then you wouldn't be able to predict. Remember, our goal as statisticians, why we use all these, is so that we would be able to plan ahead, right? And those plans would be based from the data that we collect, right? Let's end the week with the most awesome subject, maths.